back. This is going to be 6.5 day 1, and we're going to talk about how to solve non-right triangles using the law of sines. Okay, this is the second half of chapter 6. It's going to be probably a little more difficult, so it's important that we are paying attention, doing our work every day. Don't worry, this is a long process. Some of these are easier, and then you'll see tomorrow they get harder. We'll have plenty of practice days, so don't worry, it'll be okay. So first things first, let's get into the why. If you look at this left triangle, things we can use with right triangles, Pythagorean theorem, we can use sine, cosine, tangent, right, to find missing side lengths. That's what we've done in the past. So if you look here, there's many different ways to solve it. The first thing I would do is we know two angle measures. We could easily find the third. Just do 180 minus 90 minus 24, and you get 66. So this right here is a 66-degree angle. So we found x. Now we just need to find these two side lengths. So there's multiple things you could do. Sine of 66. Well, sine of 66 would be opposite, so 12 over hypotenuse, which is y. And so we could do some solving, get y on the other side, so multiply both sides by y. So you got y times sine of 66 degrees equals 12. Now remember, if you plug in this in your calculator, it's just a number, okay? So we could just divide by sine of 66 to both sides. So y equals 12 divided by sine of 66. Now in this chapter, it's important to note, mostly everything we're doing is going to be in degrees. So if you're using a calculator, make sure it's in degree mode, which I'm going to do right here. Mine is. So I'm going to type 12 divided by sine of 66, and that's about 13.1, let's say 4, let's just round there, that 100 spot. Well, you have two side lengths. You can find a third. You could either use sine again, or you could use Pythagorean theorem because it is a right triangle. I'm just going to use sine again. So sine of 24 degrees has to equal, well, the opposite side of 24 would be z. So z over the hypotenuse 13.14. Now because we rounded, z will be a little bit off. Now I'm going to tell you guys, as long as you're consistent, it'll be okay. So if I'm rounding to 2 decimal points here, just round to 2 decimal points throughout the entire thing. If you're cattywampus, you get some different answers. Just know some of your answers might vary because we rounded different decimal points, but that's okay. So here you have z divided by number, just multiply that. So 13.14 times sine of 24 equals z. Well, let's figure out what that is. So 13.14 times sine of 24 equals, I get about 5.34. And I guess I should be labeling these because they give us as in meters. So there we have it. You can use sine like we have in cosine, tangent, or Pythagorean theorem. Now over here, look at this. We don't have right triangle, so we can't use our ratios. The only thing we can figure out is this guy right here, right? Because all the angles in a triangle add up to 180. To subtract 48 and 74 from 180, you get this as a 58-degree angle. Now you can't do what we did right here over here because there's no right angles. And so that's why we need the law of sines. So the law of sines, we don't have right triangle, and it is, we can set up proportions basically. A over sine of A equals B over sine of B equals C over sine of C. Now you can do the reverse. You can do sine of A over A equals sine of B over B equals sine of C over C. Okay, that is a legal move. Sometimes it makes our algebra solving a little easier. Either way, you get to the right answer. But we're going to use these ideas to solve these triangles, okay? Now there's a couple of cases that we're going to talk about today. The law of sines you can use when you know you have angle, angle, side, angle, or side, side, angle. Now if you recall from geometry, side, side, angle, it can spell the naughty word, and so there's issues with that. And using law of sines to solve these triangles, it's called the ambiguous case. That's what we're going to talk about tomorrow. So we're not going to talk about this today. Okay, that gets a little more in depth. So right now, today, we're going to learn how to use law of sines when we know angle, angle, side, and angle, side, angle. Now, one thing to note, we're not going to do any area today. So if on the homework it says find the area, the way we would do it is that formula we used, probably 3 weeks ago to find area. It was like AB sine of A, something like that. We're not going to do that at all. So on the homework, don't do area if it asks you. We're just going to solve. So you got to find the missing side lengths or angles. Well, first off, we could find angle B using the idea that all the angles have to add to be 180. So I do 180 minus 25 minus 30, and that's 125 degrees. Now if you look here, we know a side, or we know angle, side, angle, so we can do this. Now the way we want to do it is in those fractions, we want one completely solved for. So for instance, sine of A over A, little a, you want one fraction where you have the corresponding angle measure and the opposing side's length. So the only place we have that is C, right? So if we do sine of C over C, that would be sine of 30 degrees over, well, its opposing side is 38.21 equals, now we get to choose which one we're solving for. Okay, now, sorry. I always go with the smallest angle measure. I don't think we'll see examples of this today, but if we solve using inverse functions, which I'm getting ahead of myself, it can cause some problems. So I always go with the smallest angle next. So I'm going to use A. So equals sine of 25 over A. So remember, we have three numbers. Now we just need to solve. Okay. So there's multiple ways you could do it. This is just a number right here. So we could just type that in our calculator. But I'm going to move A over, times both sides by A. So you get A times this equals sine of 25. And then I'll multiply by the reciprocal to get rid of this. Or again, you could just type it as one number and divide it over. Maybe that's what I'll do. Sine of 30 divided by 38.21. That equals 0.01308, so on and so forth. And so we're going to divide that over. So A equals sine of 25 degrees divided by 0.0130, we'll say 9. So sine 25 divided by 0.01309, and you get A is about 32.28. Let's see, I went to 5, 28, 5, 5. Man, sorry, I'm getting weird glare on my calculator. And then this would be a 1. Okay, so that's about what I get. So right here, this side length is about 32. 0.28551. Okay, so now the last thing we need to solve is little b. Now usually, if this is right triangle, we could just do sorry. Usually we could just do Pythagorean theorem, but we're going to set up another ratio. So again, we want to pick two sides that we already know. So I'm going to do the 30 and the 38.21 again. However, I'm going to do the reciprocal of that. That way it's easier solving. Either way would work. Equals, well, we're trying to find b. So you'd have little b over sine of 125. So to solve for b, all you have to do is multiply this sine over. So you have sine of 125 times this number right here will equal b. So let's plug that in. Sine of 125 times by 38.21 divided by sine of 30. And you get b to be about 62.523. Let's see, this would end up being a 6. Okay. So about 62. That looks like a 5. It's 62. And so that's how you do it. You solve using the law of sines. Now again, up here to work is a little messier. It depends on how you set it up. If you recall, you could either do it with the side lengths on top or the angle measure on top, as long as you're consistent. Okay. So let's do another one. Again, here we don't have two angle measures. We only have one, so we can't find our third angle right away. What we can do is use law of sines though. Now again, you want to start with angle and a side that are corresponding to each other that you already have, and so that would be 5.15 and 54. Okay, and let's solve for, well, let's just set it up first. Okay, so let's do sine of 54 degrees, same as 5 or over 5.15 yards. So that's this side length. Now we need to choose another which has some corresponding, at least one corresponding information already. So if you look here, the opposing side of y would be z. So these would go together on a ratio, but those would have two variables. So that'd be difficult to solve. So let's choose x and 6. Okay, so sine of x, whatever that degree measure is over 6. So now we solve. So it's times by 6, times by 6. Nah. And then this is just numbers, so let's type that in. So you get 6 times sine of 54 divided by 5.15, and that's about 0.9425. Okay, we'll say that. And that equals sine of x. Okay. Now, how do we solve for x? We got to undo it. We got to get rid of it. So what we're going to do is we can actually take the inverse. The inverse of sine will cancel out the sine and solve for x. So to get rid of this, we're going to take the sine inverse of sine of x. So we have the sine inverse of 0.9425. Now in my calculator, you could easily have this answer saved in your calculator and type like second sine and then second answer or second minus, and that'll put the answer in. So you would have the exact answer. But the sine and sine cancel out, so we just have an x here. So that's how we get the x by itself, the variable by itself. You take the inverse of that function. But now you got to do that to the other side. So we do second sine, and that's the inverse, And now we could type in our previous answer. Let's see, times sine of 54 divided by 5.15. Now again, this is being picky. I wouldn't penalize you for rounding here. However, with the sine inverse, even if you round, your angle could be a little bit different. So I'm just putting in the exact answer, and I'll get x is about 70.4. I'm gonna round to 2. And that's angle measure. So 70.48 degrees. Now from here, we need y and z. Now they're corresponding, so we could not set up a ratio yet because we would have two variables. What you should do first is use the idea that all the angles add to 180. So 180 minus 54 minus 70.48. And this angle is about 55.52 degrees. Okay. Now, this is what I like to do. I usually like to use the idea that all the angles add to 180. In some problems, you don't have to find a third. But what can happen is, for instance, let's say I got this one, and I use, in a different problem, the law of sines to find this angle measure. You might get something that's a little different that wouldn't add to 180 just because of rounding issues. So I just like to do 180 minus the two angles you already had to find a third. So lastly, we have to find z. Let's do law of sines again. Let's do, I'm going to do the reverse. That way the side length is on top. So I'm going to do 5.15 over sine of 54. Now I choose this one because this is the one we started with. You don't have to. You could certainly do you could certainly do sine of 70.48 into 6 yards. I'm just going to do this because this is what we were given. Equals, now we don't know z, but we do know its opposing side length, which is sine of 55.52 degrees. So to just solve for z, you multiply this number over there. So z would equal, I'm going to do sine of 55.52 times 5.15 divided by sine of 54. And that side length is about 5.25 yards. Okay? And so there, to solve, we found all of the missing side lengths and angle measures. Let's see, we got one more. I forget what ly is. That light? I don't know. That wouldn't make a lot of sense. Anyways, third triangle, we have two side lengths and an angle. Now if you look here, we have an angle and a corresponding side length given. That's really the only thing you need for law of sines. You do need a third angle or side length to solve, but you definitely need this. So if we don't have this, then you'll see during the law of cosines what we have to do. But let's just set it up again. Let's find, I don't know, what do you guys want to find first? Not sure why I asked that. We could find angle C first. Okay, so we got sine of 120 over 5 equals sine of, I'm just going to call it big C, over, the opposite side is 4. Well, let's times by 4. And then this right here is a number, right? So it's some weird decimal, which I'm going to plug in my calculator exactly, because now to solve for C, we're going to take the inverse. So you're going to take the inverse sine of both sides. So sine inverse. Basically these cancel out, undo each other. You have C over here. And so you type in your calculator second sine to get sine inverse. Then we got 4 times sine of 120, and then divide that by 5, and you get C is about 43.85 degrees. So we got 43.85 degrees. Okay. Now again, the last things we need to solve this angle right here and this side length. Well, if we set up ratios, we would have big T and little t, two variables, so we couldn't solve that. So we need to use the idea that all the angles add to 180. So I'm going to do 180 minus 120 minus 43.85. You get 16.15. Small angle, but that's okay. And now we can use our law of sines to solve this, okay? So I'm going to use the original, and I'm going to have the side lengths on top. Again, you don't have to do it that way. It would just require a little more solving. Sine of 120 equals, and then we're going to use this. So we got t, the side length, over sine of 16.15 degrees. Okay, so again, all I have to do is multiply this number over and just plug it into your calculator. So t equals, well, we got sine of 16.15 times by 5, divide that by sine of 120, and t is about 1.61 light years, I don't know, 1.61. And there we have it. And so hopefully that's okay for today. I haven't decided if we're going into that ambiguous case tomorrow or if tomorrow will be another work day. We will see. But with that, I will see you guys tomorrow.